In this video, we're going to cover section 4.1 in the note packet. In unit 3, which is what we're in, even though everything is labeled 4 point something, we're going to start graphing lines. So before we can graph lines, we need to know what slope is and how to find slope so that when we do get to graphing lines, we can find points to plot. Hopefully some of y'all covered this in middle school, so it'll be kind of a refresher. Don't worry if it isn't. We'll go through it like it's brand new, like you've never seen it before. Okay? So when we're talking about slope of a line, we're talking about the steepness of that line or the slant of that line. So basically how slanted it is or how slanted it isn't depends on the slope. Slope specifically is a ratio, which means we are dividing two numbers to find it. If you talked about this in middle school, you probably heard the phrase rise over run. That's how we count slope off on a graph. We count our rise, so the change up or down the graph, and then we count our run, which is the change side to side on the graph. For the rise, since that's up and down, that's going to be our y values. And for the run, since that's side to side, that's going to be our x values. Notice on the notes here, it says the slope of a line is represented by the letter m. So anytime we're using an equation, so the equation y equals mx plus b, that m represents the slope of our line. And we have a special formula for slope, which is down here in the box. We have m equals y2 minus y1 divided by x2 minus x1. So like I was saying before, the change in x divided by the change in y. And that change in is represented by the subtraction sign. So we're subtracting our two y values, subtracting our two x values, and dividing the two. So you see this little triangle here. That is the Greek letter delta, which is explained up at the top. And that word delta means change in. So again, like I was saying, when we're talking about the change in two values, we're going to subtract those two numbers. So we have the change in y, so subtracting the y's, over the change in x, so dividing by the subtraction of the x values. Alright, and we're going to keep using this formula over and over and over. So I'm going to write it down for every problem we do. Let's start looking at some examples. So example 1, they have the graph over there off to the left, but we're going to focus on the points they plotted on that graph. So we're going to be using our slope formula, m equals y2 minus y1 divided by x2 minus x1. Alright, before we can start plugging in numbers, we have to know what these numbers and these points represent. So I'm going to label my points x1, y1, and x2, y2. Doesn't matter which point you decide is which one, as long as one point together is x1, y1, the other point is x2, y2. Now that we have our numbers labeled, we know exactly where to plug them into that formula. So in the numerator there, we have y2 minus y1, so we're going to have 6 minus negative 2. And then the denominator, we have x2 minus x1, so negative 3 minus 5. Once we have our numbers plugged in, all we have to do is simplify. So we have 6 minus negative 2. When we are subtracting a negative number like we are here, we're really adding those two numbers together. So really we have 6 plus 2, which gives us 8. Then in the denominator, we have negative 3 minus 5. When both of our numbers are negatives, we can add the numbers and keep the negative sign. And then we'll simplify that fraction one step further. So 8 divided by negative 8 gives us negative 1. So through all that simplifying, we got m equals negative 1. Now there are going to be 4 types of slope we're going to talk about in the notes today, which are listed up here at the top: positive, negative, undefined, or 0. And each one of those depends on the number we get when we solve for m. So since we got negative 1 here, we know our slope is a negative slope. And we can see that in the graph over on the right because it's decreasing as we move left to right across the graph. So all negative slopes decrease as we move left to right across the graph. And again, that just depends on the number we get for m. Okay, so let's look at another one. Example 2. Again, let's write down our slope formula. So y2 minus y1 over x2 minus x1. Label our numbers. So this first point, I'm going to make it x1, y1. Second point, I'm going to make it x2, y2. Again, it doesn't matter which point is which. So let's start plugging in. y2 minus y1 gives us 6 minus negative 3. In the denominator, x2 minus x1, so we have 4 minus negative 2. Now that our numbers are plugged in, we just have to start simplifying. So when we're subtracting that negative, we know that's a positive, so 6 plus 3 gives us 9. In the denominator, again, we're subtracting a negative, so we're adding, so 4 plus 2 gives us 6. And then simplify, and 9/6 reduces down to 3 over 2. So our slope here is 3 over 2. Now this time we got out a positive number, so this is going to be a positive slope, which we can see on the graph over here. Positive slopes increase as we move left to right. So you can see the direction difference in these two graphs. One is decreasing because of the negative slope. This bottom one is increasing because of the positive slope. Alright, so those are our first two kinds of slope, positive and negative. Let's move on to talk about our last two kinds of slope, undefined and zero. Alright, so they gave us our 2 points. So we're going to plug it into our slope formula. And before we can plug it in, we're going to label our points. So just to show you it doesn't matter, I'm going to make this first point x2, y2, and the second point x1, y1. Doesn't matter which point you label as which, you're still going to be subtracting your y values and x values together. So we have y2 minus y1, so that's going to be 4 minus 4. In the denominator, we have x2 minus x1, so negative 2 minus 4. And then we can simplify. So 4 minus 4 gives us 0. Negative 2 minus 4 gives us negative 6. And then if we reduce that fraction, we have 0 divided by 6, and 0 divided by anything is 0. So we simplified this all the way down to m equals 0. Now looking at our graph over here, we see that when we have a 0 slope, this is a horizontal line. And all horizontal lines have 0 slope. Every single one of them. So anytime you're just finding slope and then you have to graph, if you get 0, then you know your line is just going to be a straight line that moves side to side, a horizontal line. Okay, so that's kind of one of our special cases. That line has no slant to it. It's just a flat line. All right, last one. So let's write down our slope formula. And label our points. So x1, y1, x2, y2, and plug them in. So y2 minus y1, we have 1 minus 5. x2 minus x1, we have 3 minus 3. Now that we have our numbers plugged in, we can simplify. So 1 minus 5 gives us negative 4, and 3 minus 3 gives us 0. Alright, I'm sure y'all have heard this before, but it is impossible to divide by 0. And the reason is, when we're dividing by a number, we're looking for 0 times what number is going to equal our numerator, -4. 0 times any number is going to be 0. So it is impossible to find a number when you multiply it by 0 that's going to equal -4. So this number does not exist. Okay? So anytime we divide by 0, our slope is going to be undefined. Since it is impossible to divide by 0, our slope then is undefined. Okay? And if you notice, look at the graph there. This time our line runs straight up and down. So this time this is a vertical line. Again, this line has no slant to it. It just runs straight up and down. So this is our fourth slope, our fourth kind of slope, and our second special case where it has no slant to it. So I'm just going to kind of put a little summary off to the side here. If 0 is on top, if we have 0 over a number, then that's going to equal 0. But if we have a number divided by 0, that's going to be undefined. We cannot divide by 0. Okay? One of my teachers once told me 0 over a number is on. We can do that. Okay? Let's write it this way. But a number over 0 is no. We can't do that. Okay? Again, that gives us undefined slope or 0 slope, depending on where that 0 is placed. Okay, so 4 kinds of slope: positive, negative, 0, or undefined. That will be on the quiz that you'll have coming up soon. So just start recognizing what those graphs look like. All right, let's move on. So example 5 here. They have given us 2 points, but if you notice in one of these points, we still have a variable x. One of those coordinates is missing. But they also gave us the slope this time, which is what we've been solving for. So we're still going to use the same slope formula, but this time we'll be plugging in a variable on the right side, and we'll actually have a number to set the whole thing equal to. So let's start plugging in numbers. We have m equals to start our formula, and we know m equals 5, so we're going to have 5 equals. And then let's label our points x1, y1, x2, y2, and start plugging in. So y2 minus y1, we're going to have 19 minus 9 over x2 minus x1, so -1 minus x. Now, when we have something set equal to a fraction, the way we can solve this is by cross multiplication. Okay, but in order to do cross multiplication, we have to have a fraction set equal to a fraction. So, because we have this whole number over here on the left, we're going to make that a fraction by putting it over 1. And once we have a fraction set equal to a fraction, we can cross multiply to solve for x. So when we cross multiply, we're multiplying diagonally across that equal sign. In middle school, you might have called this bat and ball or the butterfly method, okay, but it's cross multiplication. So we're going to multiply diagonally across the equal sign, so we'll have 5 times -1 minus x, and we're going to set that equal to the opposite diagonal. So we're going to multiply diagonally the other direction across the equal sign, so we'll have 1 times 19 minus 9. Okay, and that gets all our numbers out of that fraction, so then it's going to work just like a solving problem that we did in Unit 2. So let's get solving. We have parentheses, so we're going to distribute. 5 times -1 gives us -5. 5 times -x gives us -5x. Then we'll distribute the 1. So 1 times 19 is 19. 1 times -9 is -9. Okay, then we can simplify, or combine like terms, sorry. There are no like terms on the left here, because one of those terms has an x, but on the right side, neither one of those has a variable, so we can combine those. So 19 minus 9 is going to make that 10. And then we can start working through our SADMIP steps or working backwards through PEMDAS. So to get x by itself, we're going to add 5 to both sides of that equal sign. And then last step, divide by -5. And when we divide by -5, that leaves us with x equals -3. Okay, so only when we are missing one of our coordinates in the points they give us, that's when we're going to cross multiply. No other time, okay? Only when we have to solve for one of the missing coordinates like we have here in our point. And again, when we cross multiply, we're multiplying diagonally across that equal sign. Okay? Alright, so that's how we find a missing coordinate. Last one, I'm going to skip over these graphs. For these graphs, all you're going to do is take the points they've given you on the graph and plug them into the slope formula like we were doing in the first 4 examples. Okay, so the last one, I want to look at kind of a real world example here. So in example 6, it says the table shows the distance a girl walks and the amount of time it takes her to walk that distance. Find the rate of change in distance with respect to time and interpret its meaning. So that phrase rate of change here, that is like a real world way of saying slope. Okay, if we're finding the rate of change of a set of data, we're finding the slope of the graph that represents that data. Okay, so it's comparing one quantity to another in a ratio format, which is exactly what slope is doing. Okay, now in real world examples, they always give you more data than you need to find the slope. So here they gave us 1, 2, 3 points of data, but in our slope formula, we only need 2 points of data. So you get to pick whatever 2 points you want. It doesn't matter which 2 you pick. You can pick the first 2, the last 2, or the outer points, okay? As long as you pick 2. So I'm going to pick the last 2, and now I need to label my points, x1, y1, x2, y2. But before we can do that, we need to know what time and distance are represented by, which variables they represent. So think back to Unit 1 when we were talking about functions and independent and dependent variables. And we said time is almost always our independent variable, which is going to make time our x. It's the one that's causing this, right? She's walking for a certain amount of time, and then we're figuring how much distance she covered. So time is going to be our x, distance will be our y. So in my 2 points, I'm going to make it x1, y1, x2, y2. Again, it doesn't matter which 2 points you choose. You just have to choose 2 out of the 3 points. Okay. Now, we said our slope is change in y over change in x. So we use that formula y2 minus y1 over x2 minus x1. So if we put that in terms of what's actually happening in our problem, so time and distance, that change in y over change in x is the same thing as change in distance divided by the change in time. Okay, and we've already labeled our points, so now we just have to plug it in. So y2 is going to be 4.5 divided by y1, which is, subtract y1, which is 3, and then divided by x2, which is 90, subtracting x1, which is 60. And just like those first few problems, we have our numbers plugged in, so let's simplify. 4.5 minus 3 leaves me with 1.5. 90 minus 30 leaves me with, or minus 60 leaves me with 30. So then, for our final answer, with real-world examples, sometimes it's not convenient to completely simplify here, to actually divide that out, especially since one of these numbers is a decimal, but we can put labels to it. So if that numerator represents our distance is in miles. That's the unit of measure we're using here, so it's going to be 1.5 miles for, and then we've got 30 in the denominator, and that's our x. And the unit we're using there is minutes, so 30 minutes. So that means she's walking 1.5 miles every 30 minutes. Okay, we could reduce that down to 1 minute. How far is she getting in 1 minute? Which if we did decide to do that, it would be 0.05 miles per minute. So that's her speed here. Okay, that's the slope of our line when we would go to graph it. So big thing to recognize here, if they ask you for rate of change, they're asking for the slope. You pick 2 points, plug them into the formula like you're used to doing. Okay, so take some time before you start the homework. Watch this video again if you need to. I know I moved kind of fast, but that's the beauty of a video. You go back and watch it as much as you need to. When you're ready, grab the homework and get started.